Question number 1. So it's a trigonometry question. So firstly, they want us to sketch the graph C, y equals cos bracket x minus pi over 3 in that interval. So if we draw the usual cos x graph, so that will look like that from 0 to 2 pi, and the x-intercepts will be pi over 2 and 3 pi over 2. And with bracket x minus pi over 3, that means if we rewrite as a function, if this is f of x, which is cos x, so what we'd like to do is draw f of x minus pi over 3, really. So that would mean that in order to draw this, I could just use this graph and shift this pi over 3 to the right. Okay, let's do that. So now this is just a 2-mark question, so that shouldn't, we don't need too much detail about it. As long as the shape is right, that will be fine. So bear in mind that this is a this pattern will just repeat itself. So the pattern before this that ends at minus pi over 2. So that will mean if I draw it from 0 to 2 pi after shifting by pi over 3, I won't start here. So I will start somewhere here. So I could just draw that to the dotted line and then just carry on until I reach a point just before 2 pi. So let's do that. So it's just going to be this. It goes up slightly first, and then the pattern repeats, and then we don't need to finish that off. So it's going to be something level with this. So if I find this point, even though you don't have to for this question, so just substitute 0 into it. So that will be cos of minus pi over 3. And if you put that into calculator, you'll get a half. Okay, and yeah. So you don't really need the rest you don't really need to integrate the rest. Now B. So write down the exact coordinates where the curve C meets the coordinate axis. Okay, so we've done the first one. So the y-intercept is going to be a half. So I just need to find these 2 points. Okay, so that means I need to set our function cos of x minus pi over 3 equals to 0. Okay, and then in order to solve this equation, we don't have to use any A2 identities that we have learned. Okay, so you don't need to open this out using the compound angle formula. Okay, if you have done it, it's actually make it even harder. So all you really need to do is just use AS. So imagine that this is just y. So just set y equals x minus pi over 3, then it's just cos of y equals to 0. So then, usually speaking, I will just going to do cos inverse. So therefore, you could just set x minus pi over 3 equals the cos inverse of 0 and just find the numbers. Okay, so cos inverse equals cos inverse of 0 is just going to be pi over 2, and the next one 3 pi over 2, just like what we had on top. And once you have done it, then just add your answers by pi over 3 individually. Okay, and then you will get your answers. So the first one will be 5 pi over 6, and the second one, that will be let's just do it here. So you don't need the value of pi, so just do 3 over 2 at 1 divided by 3. So you will get that fraction. Okay, so you get 11 of 6 pi. Okay, so that will be part B. And finally, let's look at part C. So they want us to solve that equation. So again, just the same thing. So you just do cos inverse of 1 over pi over 2 first. Bear in mind that the interval that this time we're looking for, if x is from 0 to 2 pi, then you should subtract minus pi over 3 from both the upper limit and lower limit first. So you have minus pi over 3, and that will be 2 minus a third, but I believe that will be 7 over 3. Okay, so let's just double check. No, I was mistaken. So it's 5 pi over 3. Sorry, guys. And so then you just do cos inverse. So you could have power of 4 minus power of 4. And usually speaking, in order to get a third answer, you will just add 2 pi to the existing ones. So if you add 2 pi to the negative 1, say, you'll get 7 power of 4. But that number is already out of range. So we don't consider this. And so therefore, all you need to do really then just to add power of 3 again to each answer. And then you are done. Okay, so for the first one, you'll get 7 power over 12. And the second one, you get pi over 12. All right. Okay, so let's just confirm the answers by looking at the using the solve function. So we have shift setup first, make it into radians. Okay, all right. So let me just double check from the stuff before. Okay, so if I want to use this, so I will set that equation and the range. Yes, terrific. Okay, so that's fine. Okay, so let's use the solve function. So option, tail, solve and let's put our equation cos of x minus, I say minus, yeah. So shift pi divided by 3, set that equals to 1 divided by square root of 2. Okay, so now I need a range for x. Let's set that. So it is from 0 to the famous 2 pi. Okay, so there will be multiple answers. I know that. And these are the answers indeed that we have. Okay, so that is question 1 for you. So don't rely so much on the calculator. You could use it to check the answer, but there's no true substitution to what we're supposed to know. So definitely solve these questions by hand, okay? And then once you get the answer, then you could use the solve function from CG50 to check the answers. Question number 2. So what we have here is a curve C given the equation 2. And we know the coordinate of P, which is 4, 6. And part A, they would like us to find the equation of the straight line, which will be the normal to the curve at point P. So they want us to show that the equation of the straight line is 2y plus x equals to 16. Okay, so if we would like to find the gradient of the normal, what I need to find first is the gradient of the curve at point P. So I could do that by differentiate several times once. So yx cubed minus 9x squared plus 26x minus 18. So dy by dx is going to be 3x squared minus 18x plus 26. And if I would like to find the gradient at point P, so what I need to do then is to substitute x equals to 4 into it, and I'll have 3 bracket 4 squared minus 18 times 4 plus 26. Then just put it into the calculator, and you should be able to get 2. Okay. Now, so in order to find the gradient of the normal, so that is where I need to apply negative reciprocal. So the gradient of the normal is going to be minus a half. And then you could just use y minus y1 equals the gradient multiplied by bracket x subtract x1, which is 4. Then just rearrange this equation. So you have 2y minus 12 equals minus x plus 4, open bracket on the right hand side, multiply through by 2 on the left, and make the number as a subject on the right. So just group up the numbers, you will get 16. And indeed 2y plus x on the left. Okay, so in part A, what we have found so far is the equation of the normal. Okay, and let's see how is that helpful moving on. Now, so they say that the region R bounded by the curve C and together with the x-axis are normal to C at point P, and hence that area there. So firstly, they want to show, using just one mark, that the curve C cuts the x-axis at this point 1, 0. So what we could do here then is, since it's just a one marker, so what we need to do really is just to substitute the x coordinate into the curve and show that y is indeed 0 at the end. So what we need to do in part B really is just to put in x. So just say substitute x into this expression. So you get 1 cubed minus 9 bracket 1 squared, which is 9, plus 26. So you have 1 minus 9 minus 18 plus 26. So that will be 27 minus 27, which is indeed 0. So that shows that the curve goes through 1, 0. Good. All right, so now part C. Now they asked us to use calculus to find the exact value of the exact area of R. Okay, so just like last week, whenever you got a shape which is bounded by the curve, the straight line, whenever they intersect where it is not on the x-axis, I'll put a line. I'll just construct a line connecting the intersection back down to the x-axis, and then you'll be able to, if I zoom in a little bit, or if I redraw this again, so if I, from the point of intersection, if I drop a line back into the x-axis, then I could see there's a triangle that we have on the right. So I could just find the area by, as long as I know the base and the height. Okay. Whereas on the left, it is the area bounded by the curve and the x-axis. So I could find that by using integration, and then I just need to know the limits. So I will split this area into A and B, and then let's find the numbers and finish the question. So for section A, so that will be integration, and we just been told in part B, this is 1. Okay, and this point P, we also know the coordinate from the start. This is going to be 4, 6. In other words, if I want to find the area A, so I just need to integrate this curve with respect to x, and the limits that I'm going to pick is from 1 to 4. Okay, so that will be part A. And now for part B, again, this is the area of a triangle, so I just need the base and the height. Okay, so let's see how we could get that. So since this coordinate is 4, 6, so we already know that the height of this triangle is probably 6. Okay, so in order to know the base, we need to know the differences between the x coordinate here and here. So how could I get this point? So you could get it by reciting our equation of the line 2y plus x equals to 16 and setting y as 0, because this is where the line cuts the x-axis. So if you do that, then you will have x as 16. Okay, so therefore, if you just work out the differences between these two gaps here, so that is going to be 12, which will be the base of the triangle. So we could just set the area of B as base times height divided by 2. Okay, and then that should work out to be 36. Now let's just work out A step by step. Okay, because usually for questions like that, 6 to 7 marks or even more than that, any answers from straight away from the calculator is not appropriate. You won't get any marks out of it. So what you need to do is, in order to get all the marks, is to integrate this. So A again. So let me just integrate it straight away. So these are all just algebras, polynomial terms. So all you need to do in order to integrate is add 1 to the existing power. In this case, for the first one will be 4, and divided by the new power 4. Okay, so the next one is going to be 9x cubed divided by 3, 26x squared divided by 2, minus 18x. So originally it's a constant, so there's no x term. So imagine there's an x to the power of 0 after it. So if you just add 1 to the power, so that turns into 1, then you divide by a new power 1, so it's just 18x. So any constant, if you integrate it, you will have an x attached to it. Okay? And then in order to get all the marks, so you need to integrate, you have substitute the limits. So you will do 4 to the 4 divided by 4, do the substitution. You don't only show that for 4, you show that for 1 as well. Okay, so once you have done that, then you pretty much have done all the necessary steps. But remember, you must show that because otherwise you won't get all the marks. Then obviously, if you want to find the area of the integral yourself, so let's say if you're using CG50, then what I recommend you to do also is go to use the just the integration sign. Okay, remember type in your original curve, not the expression that I integrate. So just type the entire thing into it and then find the answer. So I have x to the power of 3 minus 9x squared, adding on 26x minus 18. And then we have 1, 2, 4, and then just put it into the calculator. So we have 63 over 4. Okay, but now since you have shown all the steps, so the examiner can't take any marks away from you. So A is 63 divided by 4. So in order to find R, as we mentioned, so we're just going to be adding on the area of the triangle, 36 onto it, and then you'll get the area of the triangle. So we will just add 36 to the answer that we just get. And that's what we get. 207 divided by 4 as the final answer. Question 3. So Wilma thinks there could be a relationship between two variables in a large data set, and she takes a random sample of 10 consecutive days of June from the large data set for a certain location in the UK. So that's the table. And now question A. So they ask why she should not use a linear regression model based on these data to predict the total rainfall on the day with mean temperature of 20 Celsius. So I'll explain this question verbally. So if you look into the first column, so you could see that the range of temperature that we have here is just going to be in between 10 to roughly 17. So 20 is of the range that we have. So that's why the keyword that you want to mention is extrapolation. Okay, so if we are predicting beyond the range outside, it will be extrapolation. That is what we don't want to do because that will impact the accuracy of the prediction because it is not the data available in our data set. So if it is 20 degrees, that is beyond the range that we have here, which is 10.2 to 16.5. So if we attempt to make a prediction based on that, is extrapolation. So B, she managed to calculate the PMCC for these data, which is minus 0.2663. State what does that mean? What does that measure? What does PMCC measure? So what we're trying to do for this bivariate data meaning there are two variables, is that we want to see if there's any sort of relationship between it. So BMCC is what this number for. We would like to investigate if there is any linear correlation between these two variables, in this case, the daily mean temperature and the daily total rainfall. So that's why what you want to mention for this mark is the PMCC measures the linear correlation between the daily mean temperature T and the daily total rainfall. Okay, so this is part A and B. So these are AS question up to this point. So C, now stating your hypotheses clearly and test at a 5% level of significance whether or not the PMCC should be less than 0. Okay, so in any sort of hypothesis test that we have learned, we know that we need to establish the null and the alternative hypotheses first. Okay, so we always assume that H naught in this case is going to be no correlation. So we use the notation rho. Okay, but what that means is there is no correlation. So we always assume that for H naught there's no correlation. And alternatively, H1 in this case will be what we have here. So we want the PMCC to be less than 0 alternatively. So this is what we're trying to test at 5% sequence level. So here, in order to finish this, we need to go to the formula booklet. And this is the list that you're supposed to get. This is in page 39 or 40 or 41 in the formula booklet. So this is a list of PMCC value that we have. Okay, so notice that there are two variables here. So it is either in significance level on the left, and then on the right, the sample size. So in order to make use of this table, we need to know the significance level, in this case 5%, and the total number of data, so there are 10. So the number that we're looking for is 0.5494 from the table. Okay, so this table, this number that we just had, help us to construct the critical region for this test. Okay, so the number that we obtained is 0.5494. Okay, so what I'm going to write here is after the hypotheses is from the table. I'm just going to say that under 5% sequence level, the critical value that we have is 0.5494. Okay? And since we're testing for negative PMCC, okay? Because if anything less than 0, it's going to be negative. So that's why the critical value is negative 0.5494. And so in order to use it to construct the critical region, so we call that the perfect score for PMCC is -1 for negative correlation and 1 for positive correlation. So that's why in order to construct a critical region here, so I want the score which is better than that in order to have negative correlation. So that's why the critical region for this test is going to be between -1 and -5, 0.5494. Okay, and since our number, the test statistic -0.2663 is not in the region, so that's why we'll say that there is insufficient evidence to reject H naught. Okay, so let me just write this down. So -0.2663 does not lie in the critical region. So there is insufficient evidence to reject H naught. And finally, you're just going to say that a sentence to conclude the context. So that's why you could say there is no correlation between those two variables, okay, which is the daily mean temperature and the daily mean rainfall. Okay, so I'm just going to write the letters, okay, but in the exam, you should write the whole phrase, okay, what T and R represents. Okay, question number 4 is a mechanics question that requires resolving forces. So that's a particle P at the moment at A, so it's held at rest and in an inclined plane 30 degrees at a 30 degrees angle to the horizontal. And point B which is below point A. So it's going to slide to point B when we release this at rest. So we have also been told the coefficient of friction that connects the friction with the reaction together. So we know that friction will be 0.3 of R. Okay, so let's get our force diagram for this question first, which will be the reaction, since this is in contact to the plane. That is the weight component. And since it's lying down in a rough plane, so friction here. So since this particle is sliding down or up the plane, so we want all the forces either in this direction, parallel to the direction that we're traveling along the plane, or perpendicular to the plane. So that's why the vertical downwards force, the weight, has to be resolved accordingly into these two directions. So the way that I'm going to draw the triangle will be that way. So I know that some other teachers do it differently, but as long as you'll be able to get the component correctly, that's fine. So when this is 30 degrees, then the vertical component could either be 4g, because the weight is 4g. I forgot to mention that 4g cos 30, or if you use another angle 60, you could also written this component, the perpendicular component of the weight, as 4g sine 62. So they are equivalent. The next thing is the parallel component. That will be either 4g sine 30 degrees or 4g cos 60 degrees. Again, it's the same thing. All right, so we have all the ingredients. So in order to find speed, we'll be using silver, okay, because this is going to be traveling in a constant under constant acceleration. So SUVAT, so we know that we have the velocity at the start, since it's held at rest. So it's going to move by 5 down. If we take this side as positive, we take the initial direction as positive, which is down the plane. But we are missing something, okay? So we need one more information, and we could get it, the A, by just finding F equals ma if we resolve it down the plane. Okay, so again, we're going to take downwards down the plane as positive, because this is the initial direction. So we will have down forces pointing that way, subtract the force pointing up the plane, make it equals to 4a. So we have the force pointing downwards as 4g sine 30 degrees. Take it away from the friction, which is 0.3 R. So let me just write it down there first, equals to 4a. All right. So in order to find A, you need to find the reaction. So you could just do that by equating the forces up and down the plane. So I will just make these two equal. So I'm just going to do it here. So make these two equal. So therefore you will have R equals to 4g cos 30 degrees. That's these two forces pointing perpendicular to the plane only. So just put it into it. So you have R as 4g cos 30 degrees, and you have originally 4g sine 30 degrees, all divided by 4, and you will get A. All right, so let's just toss it into calculator. So a big fraction, so you have 4 multiplied by g multiplied by sine 30 degrees. Remember to add brackets to these. Subtract 0.3 times 4 times 9.8 multiplied by cos of 30 degrees, and then divide it through by 4. Okay, so before you do that, you want to make sure that it's actually in degree mode, which is something that I didn't do. So I nearly got it wrong. So it has to be in degree mode. So change it. Degree. Why is it in radians? Why? Okay. Anyway, so let's just do that. And boom, you get the acceleration. So that will be 2.35 if you run it to 3 subsequent figure, but you could entitle to run it to 2.4 because we use GS 9.8. So any answers that round to 2.4 will be fine, will be suffice. Okay, that will be part A. So now in part B, we have introduced a horizontal force to the system which caused the particle to rest at A. And then it is on the point of sliding, moving up. Okay, so it's not moving, but if you just gently add a little bit more value to the H, then you will probably have it moving up the plane. Okay, so now it's in equilibrium. That means all the forces should balance. So let's just update our force diagram. The reaction there, the weight is still pointing downwards. And then because it's on the point of sliding upwards, friction should be pointing downwards this time. Okay, so same case, we would like the force all to be just parallel to the plane and perpendicular to the plane. So we solve this force here. Okay, and then this is since alternate angles, this is 30 degrees. Okay, so you will resolve the H into these two components. Okay, so again, your teacher might do it slightly differently. That's fine. So this is H sine 30 degrees, or it's also the same as equivalent to H cos 60 degrees. Okay, if you decide to use this angle instead, which will be 60. All right, so the parallel component is going to be either, just go right here, H cos 30 degrees or H sine 60 degrees, okay, depending on which angle you have used. So for the weight component, I'm not going to repeat myself, so I'm just going to write it down. So this is 4g sine 30 degrees and 4g cos 30 degrees. Okay, so the main misconception that we usually have for this question is we use the reaction force from before. So what we had before is that we have the reaction force as 3g cos 30 degrees. Okay, it's not the same case again for B. All right, because when you introduce the horizontal force here, when you resolve it into, break it down into different component, you could see that there's one force is also on the perpendicular component, which will change the value of the original reaction. So that's why whenever there's a new force introduced to it, you want to make sure, you want to double check if the reaction changes. Not only in inclined planes, it could also be horizontal box where you just slide horizontally. If you introduce a force like that, it does actually impact the reaction force. Okay, so please double check it when you are when it gets to part B, where there are force introduced to the system or withdrawn from the system. Right, let's get this finished. So yeah, we're just going to utilize the equilibrium information, which means we're just going to equate the force perpendicular to the plane, which is reaction force only pointing perpendicularly up the plane, equals to H sine 30 degrees add on to 4g cos 30 degrees. That's first equation that we have. The second one is we have these two forces balance as well, okay, down the plane and up the plane. So we have friction add on to 4g sine 30 degrees. That should equal to that black force there pointing up the plane, which will be H cos 30 degrees. So at the moment we have 1, 2, 3 unknowns. So that's why we should have the third one in place, which is last but not least, the one that we had before. We have been told that the coefficient of friction is a third, which will be the same for the question. So you could just use the same number again, connects the friction and the reaction. Okay, so Now, if you want to use the final equation, friction equals to a third R, so you just want to toss this reaction into it and make friction a subject and put it into there. So let me just do the rearrangement here. So friction is going to be h cos 30 degrees subtract 4g sine 30 degrees. So we'll have h cos 30 degrees subtract 4g sine 30 degrees on this side equals a third of h sine 30 degrees plus 4g cos 30 degrees. Okay, so this is how we're going to set up the question. And up to here, you will get roughly 4 marks. The rest is about accuracy. So we want to make H the subject of everything here. So we're just going to do it step by step. So as an overview, I'm going to open up the brackets on the right-hand side, and we'll put H on one side. In this case, I will just put it on the left later on, and all the terms without H, I'll put on the right, and then we'll just take it from there. Okay. Now let me finish it off. So a third h sine 30 degrees plus 4g divided by 3 cos 30 degrees. Nothing changed on the left hand side. So I'm just going to change the position of these two terms here. Okay. So we'll have h cos 30 degrees subtract a third h sine 30 degrees equals to 4g sine 30 degrees plus 4g divided by 3 cos 30 degrees. Okay? Now, just factor out the h. You'll have cos 30 degrees minus a third sine 30 degrees. The same thing on the right-hand side. And then now just divide through by cos 30, take away a third sine 30 degrees to finish it off. Okay? So that's a lot of algebra. So make sure that all the signs are correct and write down the steps as you go along, because otherwise you might get something wrong. Okay, so now let me just put everything into the calculator. So 4 multiplied by 9.8 and sine of 30 degrees. Add on 4 times 9.8 divided by 3 times cos of 30 degrees. That's the top part. Cos of 30 degrees. Subtract a third of sine 30 degrees. And this is what we get as the horizontal force H. In order to make it balance at equilibrium and the particle, which will be on the point of moving out, then H will be 44.2, or again, you could write it to 44 if you write to 2. Question 5, the bonus question. So what we're looking at here is they gave us two terms of an infinite geometric sequence, and they narrowed down the angle theta from 0 to 2 pi. So what we know is that it is in radians, and it gave us a range for theta. So with that, let's get started. They asked to find expression for r. In here, r stands for the common ratio of the geometric sequence in terms of theta. So what I could do in order to get the common ratio is if I just divide the second term by the first one, which will be 12 sine squared theta divided by 18, which you could simplify a little bit to get 2/3 of sine squared theta. And then the second one, they ask us to then find the possible values of r, the common ratio. So we need to study a little bit about this expression, 2/3 sine squared theta. Okay, so let's see what do we know about this. So we know that sine theta, by just drawing a graph roughly from 0 to 2 pi, the range of sine theta is going to be in between -1 or 1. Okay, and what about sine squared? Okay, so sine squared theta stands for sine theta squared. which means no matter what I throw into my squared function, the outside, I should get a positive number. So that's why sine squared theta must be at least 0, because this is a squared number. Okay, so sine squared theta is sine theta all squared, a square number, so it must be at least 0. Okay, and then if you take the extreme point, which is this one, when sine theta equals to 1, if you square it, it's going to be 1 again. So that's why we need to know that sine squared theta in terms of the range is going to be in between 0 or 1. Okay, if you're interested with the graph, it sort of looks like that. It's not exactly identical to sine theta, that fluctuation, but I'm just going to draw it that way. So sine theta, and then because it's a square number, so anything negative before will be squared. So that's why it's actually going to be like that as the graph of sine squared theta. Okay, and this one meant to be symmetrical, but I'm not very good at drawing, so sorry about that. So this is part A. Okay. Oh, sorry, I haven't finished it yet. So R, then at the end is 2/3 of it. So that's why for R, since it's 2/3 of it, so the range of R should be 2/3 of what I just written down. So that will be in between 0 to 2/3. So that will be part A. Now part B, it's a show that the sum of the infinite sequence that start like that, 18, 12 sine squared theta, could be written as that, 54 divided by 2 plus cos 2 theta. So let's start with what we know first. So this is a formula that you could find in the formula booklet, but I'll recommend you to remember it. Okay, so I could use it when it is an infinite sequence, which means in terms of just a common ratio, it will be in between -1 and 1. Okay, not including -1 or 1. So that will be A divided by 1 minus R. So using the first term, 18 divided by 1 minus our original, our common ratio, which we found as 2/3 sine squared theta. Okay, so that's directly applying the formula. So now notice that it looks slightly different from what they asked us to show that as, which is just one clean fraction. So R1 at the moment, it is a fraction within a fraction. So that's why what you want to do firstly is to multiply through by 3 so that you could get rid of the denominator here. So you get 54 all divided by 3 minus 2 sine squared theta. Okay, and now you could see the top is the same, numerator as 54. So what I'm aiming to do then is to sort of change the sine squared theta into cos 2 theta. So that's one identity that helped us to do that exactly, which is what we are currently learning, which is chapter 7, double angle formula. So we could use the double angle formula for cos, which we know cos 2 theta is cos squared theta minus sine squared theta. And particularly because I want to get a connection between cos 2 theta and sine squared theta, so I will just have my identity in terms of sine squared by changing that. So that will be 1 minus sine squared if you use the AS identity. So in terms of, I could have the cos 2 theta just in terms of sine squared theta. So then you have the relationship between these two. Okay. Now you could throw it into our expression there then. So this is precisely 2 sine squared theta. So we could just substitute it with that. So I have 54 all divided by 3 minus bracket 1 minus cos 2 theta, which I will end up with 54 all divided by 2 plus cos 2 theta as a result. This is what they have as well. Okay. So that will be part B. Now, building up with what we've learned in part B, then they want us to, based on this infinite sum, they want us to suggest the value theta so that the sum will always be the largest. Okay? So this is actually the part which caught my eye. That's why I want to let you guys do it. Okay, I'll let you guys experience it. So later on in this year, you're gonna learn some differentiation skills. Okay, which will be very tempting for you to use for part C, because back in AS, when we were asked to find some greatest value of some functions or some polynomial, we have been always been told to differentiate it, make the gradient function equals to 0, and take it from there. In this question, you could do this too. Okay, this is what the mark scheme also suggests as an alternate method. However, you could get away with it by doing something else. Okay, that's why I want you guys to learn this too. If your expression is written in terms of some simple trigonometry function, then probably, and actually not probably, actually you could get the sum, the greatest sum in this case, by not doing the differentiation work. Okay, so here let's look at this expression in detail. So this is a fraction, okay, and then s is depending only on theta, and theta is now sitting in the denominator. Okay, so what could we do about this? So if we just observe these two fractions where they have the same numerator but two different denominator, we could tell which number is larger. Okay, and if I have another one, 5/2, we could see that this is the largest. And here it suggests to us that if I want a fraction to be large as possible, then I want to have my denominator to be as small as possible. Okay, so we could apply this concept for this question. So if I want to have the largest s, then I want this to be small. So I want the smallest possible for this denominator. Okay, so let's look into just the denominator now. So 54 is out of the equation. So let's start by looking at just cos theta. So cos theta will be a graph that looks like that. And we know that the range of cos theta will be in between -1 to 1. What does cos 2 theta suggest us? So cos 2 theta suggests to us we will just do a transformation. That means we're just going to squash it in the horizontal direction, which means in the same duration, 0 to 2 pi, I could draw 2 of this. Okay, so I'm going to draw it like that, 2 of this. But still, it won't affect the range. So cos 2 theta will be in between -1 to 1. Okay, and then if you just add 2 to this, okay, that means if I just look at this inequality, that I'm just adding 2 to my endpoints. All right, and therefore you have the range of 2 cos 2 theta will be in between 1 and 3. So that means if I would like to if I would like to maximize my sum, so again, I want to pick the smallest possible value for this expression. In this case, it will be this, because this is the range this function takes, and this is the lower bound. So this is the smallest possible. So therefore, to answer this question, if I would like to find the values of theta, which maximize my sum, I just need to set 2 cos 2 theta, 2 plus cos 2 theta as 1. And once you have done it, then you're fine. Okay, so let's just solve this equation and finish it off. So you just rearrange it. You have cos 2 theta equals to -1. And then just solve this equation. So it's actually just solving these 2 points really. Okay, if you look at it from the graph perspective, or if you just want to solve it using algebra ways, that's fine. Just do cos inverse of -1, and you will get the first answer that it will give you will be 3 power over 2. But bear in mind, because we're solving with 2 theta, so we want to expand your interval, multiply through by 2. So it will be in between 0 to 4 pi. So the alternate answer to this is by adding 2 pi to it. So that will be 3 pi over 2 adding on 2 pi, which will give you 7 pi over 2. So these are the 2 possible answers that you have for 2 theta. And then finally, in order to finish it off, just divide through by 2. And here's your answer. 3 pi over 4 and 7 pi over 4. So this is a technique that you will use it a lot when you go to 7.6 as well, when you're doing R conversion with some modern questions. So make sure you're happy with it. Okay, so it's going to be very, very beneficial for some of our questions moving forward.